Hey guys, in this video I'm going to show you how to make sense of ANOVA output in SAS. So what I'm going to do is I will first manually calculate the ANOVA using the ANOVA formulas, and then I will compare the output which I got in my manual calculation with the SAS procedure. Here I have already written the manual steps that are involved in ANOVA. So if you see that we have only 5 steps which are SST, SSW, SSB, F statistics and F value. So this SS stands for sum of squares. So sum of squares total, sum of squares within and sum of squares between. So that's what SSW and SSB means. And for ANOVA, the null hypothesis is means are equal and the alternative hypothesis is means are not equal. Solve all the steps over here. I have a sample data in Excel and I will be using those value to calculate the ANOVA statistics, and let's compare them with the SAS output. Three categories of data A, B and C, and the grand mean for all the value is 4.066. And first let me solve the sum of squares of total. For SST, we will make use of this grand mean, which is average of all the dataset. So if we highlight all the value in our dataset, you will get an average, which you can see in our Excel bottom, which shows average is 4.066. For SST, you need to subtract each of the values in our dataset with the grand mean. So that's what I am doing in the Excel. Once the difference between each value and the grand mean is calculated, you have to square the calculated values. So now let's do that. Then sum the results. So this is our sum of squares total. Let me make a note in my manual calculation. Then let's move on to the next one, which is sum of squares within. For that, first you have to get the average for all our categories and then subtract them with their average. So for example, if a value of A should be subtracted with the average 4.2, and in all the values of B should be subtracted with the 4.6. So that's what I am doing in Excel. The calculation is very similar to what we did before. We will subtract first, and then we will take the square, and then we will add. That gives us the sum of squares between. Sorry, this is sum of squares within. So let me make a note in my manual calculation. Now for sum of squares between, all you have to do is subtract the sum of squares total minus sum of squares within. So if I just calculate the subtraction difference between these two, I will get 3.73. For F statistics, the value M is a degrees of freedom. We have A, B and C. So M is 3 minus 1, which will be 2, and in this entire formula we have SSB, SSW and M. Now the n of t, which says that number of count of values in our entire data set. So we have for each category 5 data points. So the total data we have here is, if you see the count, it is 15. So 15 minus m, which is 3, it will be gives us 12. Let's solve the F statistics in the calculator, which is 3.73 divided by 2, and that gives us 1.865. So I need to divide 1.865 with the result of 7.2 divided by 12. Let's do that now. So I need to divide 1.865 divided by 0.6, which is our F statistics, 3.108. Let's take a note in our manual calculation. For F value, I will be using the degrees of freedom. So we need to refer this chart. I got this chart from internet. So now I am assuming my significance level as 0.05. So I know that my numerator degrees of freedom is 2 and denominator is 12. If you see in my manual calculation, if you see the numerator, it's given as 2, m minus 1 is 2, and the denominator is 12. So let's go and check what the corresponding value for 2 and 12. So if you see the table, we got 3.885. We have all our calculation now. So in manual calculation, what we used to do is we compare the F statistics with the F value. If F statistics is lesser than F value, then we used to say that we failed to reject null hypothesis. So which means are equal. That's what our results shows. Now let's see the same thing in SAS. Let's I will use the procedure PROC ANOVA PROC GLM. So I have created the same Excel sheet, copied in my SAS dataset, and ran the procedure. If you see that, it will give us the same value which we calculated: sum of squares total, sum of squares within, and sum of squares between. 10.9, 7.2, 3.7, which are nothing but the sum of squares which we calculated. And the other thing we have done manually is the degrees of freedom. So that is under DF column 2, 12 and 14. So the F value here is 3.11. So if you see our manual calculation, it will be close to that. In SAS, what you have to do is you need to compare F value with P value. Our F value is 3.11 and P value is 0.8. If we closely look the SAS output, we don't have anything called F statistics. We only have F value, but in our manual calculation, we had both F value and F statistics. So the F statistics in the manual calculation is the F value in the SAS. So just don't confuse those both. And we don't have that F value which we did in our manual calculation using the degrees of freedom chart in the SAS output. So I can only compare the p value. The p value here is 0.0816, and it is greater than our significance level. Significance level is the value which you assume in the beginning of the problem, and I have assumed for this problem as 0.05. So since it is greater than the significance level, I fail to reject the null hypothesis. So if we in our Excel sheet we have seen that our means are like 4.6, 4.2, and for the C the mean is different, but they have just occurred by chances. It's not actually there is no variances. So we conclude with we are accepting the null hypothesis. Actually we fail to reject the null hypothesis. That's how we have to say. Now let's get back to our SAS output. If you see that there are so many other outputs like R square, coefficient variance, and root MSC. So you just can ignore this output. We have manually calculated it and we know that it's not required. So that's the purpose of this video. In SAS you will get automatically too much output, and which won't be really useful. Thanks guys, thanks for watching this video. Put your question in the comment section. Thank you.